Hey, this is Sam from Shure. In this video tutorial, I'm going to talk about scan peak detection and some preferences you can use to optimize your spectrum classification in Wireless Workbench 6. A really distinct feature about Wireless Workbench is its ability to load or capture scan data and then specifically process that information to inform the frequency calculator to make the most educated decisions possible when placing frequencies. But with any technology, the smarter it gets, the more configuration maybe there needs to be, or the more assumptions it can make that maybe might not align with your particular environment. So today what I want to break down is a phenomenon that maybe some of you have seen if you use scan data in your frequency coordination purposes. And it has all to do with this second threshold, the scan peak threshold. In other videos, we've talked about what this threshold does, but in a sentence, I'll summarize that it detects particularly loud peaks in the frequency domain, and when peaks exceed past that threshold, it assumes that there is an active transmitter there worth consideration of its own spacings for channel and intermod protection. Now, here's a particular scenario that I want to talk about, which is a scenario where if you're familiar with looking at this scan information, you can tell these bumps here are DTV stations. And I can tell that for a couple reasons. One, they're about 6 megahertz wide, but two, these scans coincidentally fall right on top of where DTV stations in this x-axis grid show to be DTV stations. So that looks like TV station 20, TV station 17, 22, and it turns out that these are DTV stations. Now there's something particular I want to call out too. If I zoom in, you'll see the front edge of this DTV station has this sync bump. It's a common transmission pickup that you'll see if you capture a scan of a DTV station, where at some fixed amount at the beginning of the 6 megahertz span, at least in the United States, a spike is going to be detected. Now this spike happens to trigger what we think is a scan peak. Now Wireless Workbench is really optimized to call these scan peaks, to associate equipment profiles with these scan peaks that are more akin to wireless microphone transmitters. So if I hover over that marker, which I can tell is a detected scan peak because it's a diamond-shaped marker and not a triangle, you'll notice that Wireless Workbench has by default applied a generic device IMD profile. Well, you may not be sure what that means. I'll explain it in a minute, but trust me when I tell you, this is giving this particular scan peak a wide berth, a lot of room in the spectrum, as if it were a wireless microphone system there, when in fact it's just a DTV transmission. So what I want to do is to prove to you the impact of having these scan peaks being labeled, whether it's by DTV stations or otherwise. So I've added 32 systems of PSM 1000, and I'll calculate these frequencies and see how many I can find. So with all these scan peaks here, I can only find about 19 out of 32 frequencies, which is a case that maybe many of us might find ourselves in from time to time, especially with as many DTV stations or active spectrum as we have here. So now what I want to do is I want to prove to you that these scan peaks, that Wireless Workbench thinks these are scan peaks, is actually a problem for us because instead of acknowledging these as DTV stations, we are assuming that there's a transmitter right there, a microphone transmitter, which is not the case. So Wireless Workbench enables us to exclude certain DTV stations if we know that there's TV 17 is active. I just want to make sure I exclude this. There's a benefit in doing so, as opposed to just letting loud scan noise keep us out of this range, and I'll show you why right now. In the Preferences dialog in Workbench, there are some coordination settings, specifically in the exclusion detection from applied scan data area. This bottom one is the one I want to call out. We will ignore scan peaks within an excluded TV channel. So what this is saying is if there are any scan peaks within a DTV station or any a broadcast channel, Wireless Workbench will not take into account any scan peaks from that scan peak threshold. You'll notice when I turn this exclusion on just by right-clicking and saying exclude it, that peak went away. So this is an encouragement to say if there are DTV stations captured in your scan, it behooves you to just go ahead and exclude these. Now I'll do these manually just for simplification, but if you did a TV station lookup based on your location, that would probably be just as, if not easier, to put in your zip code and exclude those DTV stations. So I'll just exclude these really quickly. By the way, if you didn't know, it's very simple to exclude just from the coordination plot by right-clicking on the TV station and hitting exclude, and away we go. That's a pretty low power station. I'll take my chances. So now, something as simple as excluding those DTV stations removed all those scan peaks from my coordination workspace. You'll notice the diamond markers went away, and even though the scan goes above that scan peak threshold, no markers are going to be placed where a DTV station is excluded. So now what I'll do is I'll re-coordinate, and let's see how many frequencies I find. So already, instead of 19 or 20, I'm finding 24, maybe more. Now, why am I finding more frequencies if I excluded more spectrum? Well, everything has to do with those detected scan peaks. And for that, I want to show you one setting. It might sound a little esoteric, but I think the math will help you see what I'm talking about here. If I go into the Equipment Profiles dialog, you can see all of these generic profiles that we've included in Wireless Workbench. This generic device IMD profile is the one that is by default assigned to scan peaks that exceed the exclusion threshold. And if I go into this Filtering and Intermods tab, you'll see that even in its standard configuration, well, they're all the same actually, 800 kHz channel spacing on either side of one of those peaks is protected, meaning unusable spectrum by any other channels with an 800 kHz margin, far more than we would even typically consider with a contemporary wireless microphone system. Not to mention insulation by 400 kHz from two-tone third-order intermods. What this means is, when we detect a scan peak in the coordination workspace, we're giving it a whole lot of space, making sure that whatever is there, any frequencies Wireless Workbench coordinates won't violate that frequency. Now, in the case where there is a carrier out there, someone else's, like if we look at this scan here, that looks a lot like a wireless transmission from an audio system we would expect. That's maybe a good thing. We don't want to interfere with this frequency, whatever that thing is. And so that being a scan peak is totally okay. But the attribution of scan information for scan peaks or scan peaks within DTV stations is an inappropriate classification in this particular case, and it had a 5 frequency discount what we took for our PSM 1000s, and just by excluding these DTV stations and having that preference enabled, we were able to squeeze out 5 more frequencies. Now I want to show you one other thing just in case you want to dig a little bit deeper. Wireless Workbench has the ability to customize, or it lets you customize, what equipment profiles are associated with those scan peaks by default. And that setting is right here. I can classify scan peaks above the scan peak threshold as, and then choose any one of these generic profiles. I can turn the feature off, or I can customize whichever profile I choose. Maybe I want to define a customized version of one of these, or let's say classify all scan peaks as something like UHFR. If I know there's a lot of UHFR out in my environment, you can do whatever you want. So this is highly customizable. And when you make this change, what will happen is all of the existing scan peaks that were detected will be reclassified as that particular profile. I know this tutorial was a little in-depth, but I wanted to make sure I explained both scan peak detection and how, in certain circumstances, it can have some unintended consequences, especially when it comes to DTV channels captured in a scan. If you've got any questions or comments, please be sure to let us know down in the comment section below. Thanks.